So this video is going to go through questions 11 to 19 on paper 6, June 2018. So it's the second half of that calculator paper. So question 11 is proving that triangle ABC is congruent to triangle ACD. So the first thing, congruent means exactly the same. In terms of answering the question, to prove that two triangles are congruent, you need to use the rules, which are side, side, side. So if the three sides on this triangle are exactly the same as this triangle, that would be one way of showing that they must be congruent. There's also side, angle, side. So if we know two of the sides on this triangle are the same as two of the sides on this triangle, and the angle between them is also the same, then again that would show that the triangles are congruent. So it's really important to say that the angle must be between the two sides that we know are the same. Then we have angle, angle, side. So two angles and any side. So if two angles on a side on this triangle are the same as two angles on a side on that triangle, then they must be congruent. And then finally we've got RHS. So if there's a right angle in both triangles, the hypotenuse is the same, and another side on the triangle is the same, then the two triangles must be congruent. So in this question, we've got lots of angles given to us. So chances are it's going to be one of these. And the fact we've got quite a few angles would suggest it's probably going to be this one. So we've got here, this angle is 80, this one is 56. I know that angles in a triangle add up to 180, so I can use that to help me work out this angle here. So if I add up the two that I've got, these two here, that makes 136. If I take that away from 180, I get then that this angle here must be 44 degrees, which you'll notice is the same as this one down here. So if this is 80 and this is 44, and that means this one is 56, it's going to be the same on this triangle. So this one is 80, that's 44, this one here must be 56. So we know that all three angles are the same. Unfortunately, that doesn't prove that they are congruent. What that does is prove that they are similar triangles at the moment. So what we want to do is actually show, well, it's better than that. They are actually congruent. And we need to pick one of these rules. So the fact three angles are the same, we need one with a lot of angles. It looks like it's going to be this one here, doesn't it? So we know at least two of the angles are the same. But we also now need to show that actually one of the sides is the same as well. So the fact that they are both sharing this side AC. The side AC is in triangle ABC, and it's also in triangle ADC. So therefore they have a side that is the same, and they also have at least two of the angles that are the same. It doesn't matter which two we decide to say they are, as long as we show that at least two of them are the same. Therefore, with the side as well, they must be congruent. So in terms of what to write down here, I would first of all begin by just choosing two of the angles and saying they are the same. So I'm going to go for the 80s. So that's going to be angle ABC. So I'm going to say angle ABC is the same as angle, and the other one is ADC. So angle ADC. So those are both 80 degrees, so they are the same. I'm then going to say that I could choose the 56 or the 54. Remember, it doesn't matter. I'm going to go for the 56s. So angle BAC. So angle BAC is the same as... Right, so which one was it? The same as this one here. So that's going to be ACD, because we go with the middle letter. So ACD. So now the last thing is to say that a side is the same, and that's AC. So I'm going to say that both triangles share the side AC. And you just need one final line to state which of these rules we have used. So we have used AAS, and it's fine to quote that. You can just say, therefore, using AAS, the triangles are congruent. So actually that's not a bad question. It may be a topic that you haven't done quite so much in class. I know certainly I haven't done it quite so much with my group, so that's something I definitely Need to make sure we do a little bit of. But yeah, actually that question is not too bad. Right, the next one is to play on words here, very similar to the one before it. But this time we are trying to show that they are similar triangles and not congruent. So to show that they are similar, there's two ways really, you either show that all the angles are the same. So that's one way of doing it. The other way is to show that all the sides are in the same ratio. So what that means is that you are timesing basically the scale factor is the same for all the sides. So like this one here, if I was timesing that by 2 to get that one, I would also need to times this by 2 to get this one, and I'd also have to times the hypotenuse by 2 as well to get this one. So there's different ways of doing it. I'm going to first of all work out what this side here is. Now it's right angled triangles, so therefore it's going to be SOHCAHTOA or Pythagoras. Well, if I'm trying to work out this side, first of all, it's going to be Pythagoras. It's the longer side, so I would need to do 4 squared plus 8 squared and then square root my answer. So 64 and 60, that's going to make the square root of 80. So when I square root 80, then I get an answer of 4 root 5 it tells me. I'm going to keep it as that for now to make sure it's really accurate. So 4 root 5. So you can either now decide to go down the scale factor route or the angle route. So I personally am going to go down the angle route. I'm going to try and find this angle here. First of all, so if I look at this triangle here, I know that this is the hypotenuse. This one is my opposite, and that's the adjacent. Now we do actually know all 3 sides, so it's up to you which 2 you tick. I would suggest that you tick the O and the A, just because those are the ones that the exam have given us, so we know that those are definitely correct. But you could have picked like A and H or A and O. So that tells us if it's A and O, it's going to be the triangle TOA. I'm going to cover up the T, angle's always bottom left, and you do O divided by A, so 8 divided by 4, and it was the tan triangle, so I need to do tan to the minus 1 of that answer. So tan to the minus 1 of 8 divided by 4 is 63.4 degrees, so 63.4 degrees. So if I know that one, I can now work out this one by doing 180 minus 90 plus 63.4. So that gives me an answer then of 26.6. Right, so what I now need to do is work out the angles in this triangle now. So again, I already know that one of them is 90, so we already know one of them is the same. So I'm now going to work out this one down here. So angle QPS. So to work out QPS, again, it's a right angle triangle. So that's my hypotenuse. Here's my opposite, that's the adjacent. So I know the opposite and I know the hypotenuse. So this time it's going to be the sine triangle. Again, angle, bottom left, O divided by H, so 4 root 5 divided by 10. And this time, because it was the sine triangle, I need to do sine to the minus 1 of that answer. So sine to the minus 1 of that, work that out as quickly as I can for you. So that is 63.4, which you'll notice is the same as the angle up there. So therefore, angle QSP, this one here, must be 26.6 because again, angles in a triangle should be adding up to 180. So angle QSP is going to be 26.6. Okay, so therefore all 3 angles are the same. So the triangles are similar. Right, question 13. This is a really nice question. So we need to work out the volume of a sphere with radius 6, and you are given the formula here. So the volume is 4/3 times pi r cubed. So we would need to do 4/3 times pi times r cubed, so times 6 cubed. So it's just a case of typing that in on your calculator, and really it's just knowing that that means you times them all together. That's really the only thing that is testing in this particular question. After that, it's just substitution. So you get 288 pi. This is a calculator paper. It doesn't say to leave your answer in terms of pi, so therefore I'm going to change it into a decimal. So it says 904 point. Does it say how to round the answer? No. So I'm going to round it to one decimal place, 904.8. So that's a really nice question. Easy 2 marks to get. Okay, this one, there's a lot involved in this one. So we've got a pyramid with a hemisphere in it. When the hemisphere is cut out, it reduces the volume by 30%. So what that's telling me is that the volume of the hemisphere is 30% of the volume of the pyramid. So the first thing I'm going to do is to work out the volume of the hemisphere. Now remember, it does remind you here, a hemisphere is half a sphere, and we had the formula for a sphere over here, and we actually worked out the volume of a sphere with radius 6, which is the same as this, but we just want half of it. So what I'm going to do is get my 288 pi, to be super accurate, get my 288 pi back like that. I'm going to divide that by 2, so it's obviously going to be 144 pi. So the volume of the hemisphere, I'm going to put here just to show you what I've done. So 288 pi divided by 2, so that is 144 pi. Right, what do I know about the volume of that hemisphere? Well, I know that when it's cut out, it reduces it by 30%. So this must be 30% of the volume of the pyramid. So I know that 144 pi is 30%. What I want is the whole percentage, the whole 100%. So I'm going to work out 1% by dividing that by 30. So that is 24 over 5 pi. I'm going to keep it all in terms of pi for now because it's more accurate. And then I actually want the original 100%. So I'm going to times that by 100. And so I get 480 pi. So what that tells me is that that must be the volume of the whole pyramid. So I know the pyramid now has a volume of 480 pi. So we're trying to work out the perpendicular height. So the only thing really we haven't used it is this formula here. So the volume of a pyramid is 1/3 times the area of the base times the perpendicular height, and it's that we're trying to work out. So let's just put in what we know. So 1/3, I can keep that the same. Area of the base, so it's a square. It does say up the top here, it's a square base pyramid. So the area of the base is just going to be 15 times 15. Right, here we get to the bit we don't know. So times the perpendicular height. So I'm just going to write PH for perpendicular height. And I know that that volume equals 480 pi because I've just worked that out. So to get this, I just divide by the bit I don't want. So basically all of this, I'm just going to do 480 pi divided by all of that in a bracket. And that is going to give us our answer. So 480 pi divided by, and then just what is in that bracket. So 1/3 times 15 times 15. Oh, trying to put 25. There we go, 15. So that gives me then 20.1. It doesn't say how to round the answer, so I'm just going to leave it as 20.1. Okay, the next question, you can see that we've got the dimensions that have been, it says correct to one decimal place. As soon as you see something like that, correct to something is going to be to do with upper and lower bounds. The house uses 4,663 standard bricks placed end to end, the bricks from the house would definitely reach over 1 kilometre. So if we look at the length of the brick here, 21.5, that's the longest measurement. So we want to look at that one to see, are they going to go over 1 kilometre? And will it definitely go over 1 kilometre? So if that's the longest measurement, we want to say, is that always going to go over 1 kilometre if there's that many of the bricks? So we need to think about what's the smallest. We know it's to do with upper and lower bounds. What is the smallest that could be? And remember, upper and lower bounds, you make the last digit 1 less and put a 5 on the end. The upper bound would be 21.55. In this case, we're looking at this one, because if that's the smallest it can be, we want to see, will this many bricks make it always go over 1 kilometre? Because obviously if it works for this one, it's definitely going to work for that one because that's even bigger. So we want to check it with the smallest one. So I'm going to do 21.45 and I'm going to times that by 4,663. So that gives me 100021.35. So the reason then this is so big is because that is in centimetres. We've got to see, is it over 1 kilometre? So first of all, I wouldn't try and be too clever and do this in one go. I would change it into metres by dividing it by 100. So dividing that by 100 is 1,000.2135 metres. And then there's 1,000 kilometres in a metre, so divide it by 1,000. So that is going to be 1.0002135 kilometres. So it is very close, but that is slightly over 1 kilometre. So G is correct. I would say she is correct actually, because as it is over 1 kilometre, just to make it really clear that we understand that's bigger than 1 kilometre. Part B. So a standard brick should weigh 2.8 kilograms, correct to 1 decimal place. A truck can carry a maximum load of 20 tons. So again, correct to 1 decimal place. So first thing I would do is just write down the upper and lower bound of this. So 2.75, 2.85. In case you do the rest of the question wrong, at least you're going to get some marks for recognising that you do understand it's to do with upper and lower bounds. So a truck can carry a maximum load of 20 tonnes. Calculate the maximum number of standard bricks that the truck should be able to carry. Now you've got to be careful because this is tonnes, that is in kilograms. So there is 1,000 kilograms in a tonne. So I need to times 20 by 1,000. So it's going to be that. And again, you want to see what is the maximum number of bricks that the truck should be able to carry. So therefore, I'm going to assume that they are the heaviest they can possibly be. How many of those will it take? So divided by 2.85 to see how many of those fit into the 20,000. So that is 7,017.543859.6. Now obviously it's not going to be able to carry that many. So therefore it's just going to be this part here, the 7017. Explain why your answer to B part 1 may not be possible to achieve. Well, we're saying that it's possible in terms of the weight to be able to do that, but there may not actually be enough room in the truck in the first place. So I would just put here, there may not be enough room in the truck. Okay, so although it can take the weight, there may not actually be the space in the truck to fit those bricks. Right, question 15 is a compound interest question. It's slightly different to the usual one because we don't know the percentage interest. So it's for 2 years. So it would be 1,200 times, I'm just going to put a question mark, times something. And if it's for 2 years, it would be to the power of 2. And I know after the 2 years, we get 1,379.02. So again, when you've got things times like this and you're trying to work out this, you just divide by the thing you don't want. So I don't want the 1200, I'm trying to work out this. So I'm going to do 1379.02 divided by 1200. So that is 1.149183333. I'm writing it all down to keep it accurate. I don't want the question mark squared, I just want the question mark. So the opposite to get rid of the squared is to square root. So I'm going to square root my answer. So I get 1.071999689. Right, so I've now got to calculate R. So remember, when we do multipliers, I'm just going to do a little bit over here. If you're increasing it by 5%, remember that makes it 105%, which is 1.05. So 1.05 would be a 5% increase. So if I've got 1.071999689, it's this part here that's telling me what the percentage is. So it's going to be, if that was 5%, this is going to be a 7.1999689% increase. So I'm going to, it doesn't say how to round it, so I'm going to say that is 7.2 because that's nice and easy to round that to. Right, question 16, we've got a box plot. So the median is just this line here. So just make sure you're always reading your scale really carefully. This one is quite a nice one to do. So it's just going up basically as you would expect it to. So this is going to be 35,000 here. So this must be 37,000. Interquartile range is the upper quartile minus the lower quartile. You can see it's 2 marks. So make sure that you don't try and be clever and do this in your head. Make sure you write down what they are. So the upper quartile is going to be 43,000 minus the lower quartile, which is 21,000. So 43,000 minus the 21,000. So that's going to be 22,000. Right, part C, we now need to complete the box plot. So the highest paid worker earns 85,000. So I'm going to put a line on 85,000. The lowest paid worker earns 20% of the salary of the highest paid worker. So basically we need to work out 20% of that. So 20% of 85,000. So there's different ways that you can do this. I'm going to divide it by 100 to work out 1%. And times it by 20, but you could work out 10% and times it by 2, so it doesn't matter as long as you can get the 17,000. So I'm going to mark that on now as well, that's the lowest one. Then it says 25% of the workers earn more than 50,000, so that is the upper quartile. If 25% are above it, then that means that must be the upper quartile. 25% of the workers earn less than 28,000, so that is going to be my lower quartile because a quarter of the values are less than that. And then it tells you the median salary is 37,000, which would be here. Obviously, really, you should be using a pencil and a ruler. And then you just join it up to make the same box shape that was in part A. Right, so then the two comparisons between this one and this one here. So the two things that they really like you to comment on are the medians and the interquartile range. Now, I always say that you should be saying a maths bit and then what it means. So the maths bit is basically which one has the higher median. So this one has a median of 37,000. This one also has 37,000. So I would put the maths bit is the medians are the same. Right, what does that mean in terms of the context of the question? So this is to do with salaries, isn't it? So therefore, if the medians are the same, the median is an average. So the average salaries are the same. Right, interquartile range, so we've already worked out this one was 22,000. This one is going to be 50,000 minus the 28,000. So that's going to be 22,000. So therefore the interquartile range is also the same. So again, that's going to be the maths bit. Then you've got to think, well, what does that tell you? So the maths bit is the interquartile range is 22,000 for both. So what the interquartile range tells you is how consistent the values are. So if one has a smaller interquartile range than the other, you would say that they are more consistent. Obviously, in this case, they are both exactly the same. So the interquartile range is 22,000 for both, which means the salaries have the